Hey guys, so I'm here to talk to you today about the idea of continuity. So this is an important definition in a discussion we're going to be using all year. So we're going to define it like this. I'm going to give you kind of a hand-wavy definition, and then I'll give you the more rigorous definition. So we're going to say a function is continuous if you can draw it without lifting your pen or pencil. Draw without lifting your pen. Okay, so here are examples of functions that are continuous, which a lot of times I'll abbreviate as CTS. So if you have a function just like a normal curvy function like that, that's fine. That's continuous, right? I can draw that whole function. Same with a horizontal line. I can draw a horizontal line. And even if I have something that has like an absolute value, like sharp corners like this W, it's still something that is continuous. I can draw it without lifting my pencil. So some things that are not continuous. So some examples of functions that are not continuous. So maybe something with a jump, something that comes up and then jumps down to another point. It could be something with a hole in it. So we've seen these before. So where there's one point that's missing. So technically I would have had to like pick my pencil up to get over it. And same thing, even if there's like a dot up here or even if there's not, it's still not continuous because I have to lift my pencil to get over that hole. And obviously if you have like a vertical asymptote, same thing, it's not going to be continuous there. Okay, so this is a jump, and these sometimes they sometimes come from piecewise functions. This is what's called a hole or a removable discontinuity. And the reason it's a removable discontinuity is because if you were like able to somehow pick up this red dot and put it in the hole, it would no longer be a discontinuity. You'd have a continuous function if you could fill that dot in. So this happens, for example, if you have, say, the function that looks like this. Say your function is, 3x squared times x minus 1 over x minus 1. Like, this is the kind of thing where the x minus 1's cancel. It has that hole at x equals 1. And of course, this is a vertical asymptote because you have to lift your pen up to kind of get from the top part to the bottom part. So the vertical asymptote, like 1 over x has an asymptote of 0. Okay, so that's like the hand-wavy definition. Let's talk about like the math definition of what continuity means. So we talk about continuity at a point. So a function is continuous at a point. If there are three things that happen. One is, and we'll say some point x equals a. And the first is the function exists at that point. So we have a value for the function. The second one is the limit as x goes to a of f of x exists. So the limit exists at that point. So the function exists, the limit exists. But the most important part, and all three of these have to be true, is that the value equals the limit. So the value at a is equal to the limit at a. Okay, so looking at kind of the graphs above, right? In this case, the first case, the limit does not exist here. If you look at this one, the function might not exist if there's no hole, or the limit does not equal the function. And in this case, the f does not exist, but the limit also might not exist, so it's a total mess. So those are kind of examples of where what it might look like in terms of math with the limits and the actual function. Okay, so that's the definition, and that's kind of an important definition. So most functions you look at, we talk about continuity on an interval. So most functions are continuous on the interval from negative infinity to infinity. Now, not everything is, but certainly any kind of like polynomial or a trig function. Actually, I shouldn't say trig, I should say sine or cosine because the rest of them have asymptotes. So sine or cosine, or an exponential function or an absolute value function, something like that. So if I ask for like, y equals x cubed minus 2, where is it continuous? It's continuous at all values. Whereas y equals cosine of 3x minus 4 continuous, all values, no matter what you plug in for x. Okay, so a function is discontinuous. I'll do red for bad. So a function is discontinuous, just giving an equation, at points with a problem. And what I mean by a problem is like your function is undefined. So that could happen where you have a divided by 0, or you have like the square root of a negative number, or you have the natural log of 0. So those are kind of the issues where a function might not be continuous. It might also be like, look at the transition on a piecewise function. Okay, so for example, if I give you like, say the example, f equals 3x plus 4 over 2x minus 5, okay, you look at something like this. This is continuous at all points except where the bottom is equal to 0. So instead of trying to see where something is continuous, try and see where it's not continuous. So all points except where 2x minus 5 is 0, so where x equals 5 halves. So ever except 5 halves, this is a continuous function. If I gave you something that looked like this, say g is 2x times x minus 1 over x minus 1 times x minus 3, this is an example that is not continuous at x equals 1 and then x equals 3. It's continuous everywhere else, but not at those points. So even though the x equals 1 or the x minus 1's cancel, so because the x minus 1's cancel, that's the example of a hole or a removable discontinuity, but there's no cancellation on the x minus 3. So that would be an example of a vertical asymptote. So if you get an equation like this, it's tempting to just like cross out the x minus 1's right away, but you still have removable discontinuity at that point. That's where you have that hole. So this looks like the graph of 2x over x minus 3. So this looks like the graph of y equals 2x over x minus 3, but we have a hole at x equals 1. All right, so that's how you can find out where something's not continuous, and you can identify the removable discontinuities. They come from like the terms that cancel out. That's where you get a removable discontinuity, wherever that x minus 1 equals 0. That's where you get the x equals 1. Okay, so let's look at a piecewise function, for example, because this is something interesting. So say we have 2x plus 5 when x is bigger than 3, and say 3x minus 2 when x is less than or equal to 3. And I might ask, is this function continuous at x equals 3? Okay, and then I'm going to ask you to go ahead and do this. So let's think back to the definition. So we're going to need to find f of 3, and then we're going to find the limit as x approaches 3, and then ask, are they equal? So basically what we're trying to see is, do these two sides meet at the point where the function happens? Is it the same on both sides? Is it going to the same place? Okay, so f of 3, that's the bottom case where x equals 3. So f of 3 is 3 times 3 minus 2, that's 7. Okay, so what about the limit as x approaches 3? Well, we definitely need to consider, both sides. Both sides. So as we take the limit as x approaches 3 from the left side, that's less than 3, we get the same thing, right? We get 3 times 3 minus 2, which is 7. If we take a limit from the right side, the limit as x goes to 3 from the positive side, though, we see the other one. So that's 2 times 3 plus 5, which is equal to 11. I should put the f here. I want to be pretty good. Okay, so does the limit exist? And the answer should be no, right? You see different values on the left and the right. So these limits, the limit does not exist. And if the limit doesn't exist, it can't be continuous. So the general strategy here is just kind of check both sides, see if you get the same thing, see if the point is at that. That's how you want to do like a piecewise function that you have to figure out if it's continuous at a point. Now, there's another fun type of problem, is what if you have a piecewise function that you want to make continuous? So I really like these. So suppose I tell you g of x is 1 over x squared plus 1 if your x is less than or equal to, I don't know, say like -1. And then it's x plus k if your x value is greater than -1. And what you're trying to do is you're trying to find the value of k that makes g continuous. So you get to play God in a sense. You get to set the two sides equal and force them to be continuous with a certain k value. So when you see a problem like this, a lot of times they'll tell you that k is just some constant that you're trying to solve for. Okay, so find the value of k that makes this continuous. Well, your thought process should be, okay, if it's continuous, the only real issue, right, is going to be at the transition point. So we need to make sure at the transition point, at that -1, so I need the left side must equal the right side at x equals -1. Okay, so the left side there is 1 over x squared plus 1. So we want that to equal x plus k. So we need the left side equaling the right side. But you might get a little flustered because you have x and k. But then remember, we're just looking at what happens at that one transition point. So -1 is where we switch from the top equation to the bottom equation. So I need the two sides to be equal at -1. So I'm going to plug in x equals -1. Okay, so I'll plug that in. -1 squared, so that's 1/2 equals -1 plus k. So I'm going to get a k value of 3/2. Okay, so that's the answer. That's the k value that makes this continuous. If you're wondering what's happening on like the visual side of things, basically you have this function, the 1 over x squared plus 1 kind of comes up and looks like that. It's like a bell curve. And then it goes towards this point right here, which is a solid dot. Now x plus k, those are all the lines with a slope of 1. So what we're doing is we're saying, okay, what is the k value that makes this continuous? We're trying to figure out which is this line that if we just plug that in, we're going to get a continuous function that kind of meets at that point. That's what we're trying to find in this problem. Okay, and same thing on any problem like this, any of these find k's, basically just set the two sides equal. Set the two sides equal. And then plug in the x, and then that'll let you solve for the k from there. It should be a relatively easy algebraic thing. Okay, so that's continuity, really big idea. Make sure you know what the definition of continuous means, and I'll see you guys soon. Thanks.